Hello YouTube, and today we're going to be doing chapter 9. But before we carry on with chapter 9, I need to tell you that I did two things off camera. One is I did a backup of the LFS system so far as a gunzipped image. This I spent about 10 minutes working out the best way to do it, and then running that. So I now have a complete system image of what's done so far. And then I did run this strip command at the time when I was recording the last video. I was a bit off my game, wasn't feeling very well, and I decided to skip this as this looked a bit scary. And I just took my own time to do this, which was the backup. I also took a backup of the actual virtual disk. So I've got a copy of that sitting on my hard drive somewhere. So it all goes to pot. I've got two backups, but that hopefully should be a problem. I think we're good. So we've done this cleaning up, and we're onto the system configuration, and we're going to read the introduction. Now, a lot of this I haven't read in a long time. Probably in about 20 years, so it'd be good for me to go over. And we're just going to read through what's in here. This won't be. I suspect a lot of this chapter will be a little bit boring. However, I think it's worth going through. So it says here, creating a Linux system involves several tasks. The process must mount both virtual and real file systems, initialize devices, check file systems for integrity, mount and activate any swap partition or files, set the system clock, bring up the network, start any daemons required by the system, daemons to services, and accomplish any other custom tasks specified by the user. Process must be organized to ensure the tasks are performed in the correct order and executed as quickly as possible. Okay. So this is like just basic boot stuff. You'll probably see this fly by your terminal in most Linux distributions. This got a Plymouth boot screen. It does all this stuff. Like check file system for integrity. If you have a bad shutdown, which is basically every time a laptop runs out of battery, it will busk the root file system and my home partitions and basically fix them up so they're not in an inconsistent state. So let's read section 9.1.1. Going to take a sip of water. It's been quite high here. So System 5. System 5 is a classic boot process that has been used in Unix and Unix-like systems such as Linux since about 1983. Now, there are System 5 Unixes. I think Solaris is a System 5 Unix. So I think this is Solaris System 5. A bit shame because Linux is kind of SV for System 5. So I'm not sure if this is the same thing. There's different, but there's different little system. Like System 1, System 2, System 3, System 4, System 5. There was owners of Xenix, SCO. God, this is going back. There was a SCO Linux lawsuit going on for decades. So I think does this? I'm not sure. I'll have to do some reading on that. I won't bore you by going through Wikipedia, but basically this is like a pre-Linux thing. This is about 1983. That's when I was born. It consists of small programs in it that sets up a basic processes such as logging via Getty and runs a script. The script, usually named RC, controls the execution of a set of additional scripts that perform the tasks required to initialize the system. The init program is controlled by the etc init tab file, and it's organized into run levels that can be chosen by the user. Yeah, so if you screwed up your NVIDIA driver install back in 2003, which was basically all the time, you'd have to get chroot into your Linux, set the init tab to like run level 3, and then fix the system. That sometimes you would have to do that. Oh, maybe you could have just got into another TTY, but I remember having to set run level 3, I believe. Yeah, 5 is full multi-user mode with display manager. So display manager is something like GDM or LightDM, which is what you use to log into. That runs, that sort of manages your X sessions, I think. I'll probably get that wrong, so don't take that as gospel. Run script. Right, this script, yeah, Will's here. Right, so the file is organized into run levels that can be chosen by the user. Yes, in LFS they are used as follows: 0 is halt. Yeah, run level 0 is like shut down. Single user mode. That's basically when you're rescuing the system. User definable. Full multi-user mode. So this is basically a text console with multi-users. User definable. I've never heard of anybody using 4 really. 4 multi-user mode with display manager. 6 reboot. The usual default run level is 3 or 5. So I think if it's typically a server, it'll be like without display manager, without a display attached or X running, it will be 3, and 5 for desktop usually. So the list of the advantages is established and a well understood system. It's been, you know, been around for 42 years. Easy to customize. Disadvantages: maybe slow to boot. A medium speed base LFS system takes 8 to 12 seconds, where the boot time is measured from the kernel message to the login prompt. And people were saying that isn't a big deal, but my Debian machine will, and my laptop will literally boot within around about like 5 seconds. So it's a little bit slower, but 10 seconds for a 20 seconds, less than a minute for a full reboot isn't a big deal. I remember when reboot it used to take like several minutes. Network connectivity is typically established about 2 seconds after the login prompt. Okay. Serial process of boot task. This is related to the previous point. A delay in any process, such as file system check, will delay the entire boot process. This happens in System D. So Debian will hang on a process for about a couple of minutes while it's trying to shut it down, or it's hung. And I usually just hold down the power button, because usually I just want to reboot and I'll let Fusk sort out the file system on the way back up. You know, I'll probably put a big Chad meme or something like that over there, over this part of the video, if I edit it. Does not directly support advanced features like control groups, C groups, and per user fair scheduling. Right, so C groups you might need for a lot of things like Docker. I'm not sure. We'll find out. Because I'll probably want to use Podman and Docker on this machine eventually, if I ever use it as a real desktop. Adding scripts requires manual static sequencing decisions. Yes. So you have to control this yourself, basically it's saying. Right. Right, so we need to go back to sources. So I think it's the tar XF procedure again. So if you're not familiar, we have to follow this process, which is we go into the sources directory, we untar the program, untar the archive, we change into the directory where it was extracted, run the commands that are listed, and then delete afterwards, delete the folder afterwards, which is probably what we're going to have to do here again. So we're going to do tar-xf, so I'm saying this Bootscripts, and there we go. So tar-xf LFS Bootscripts, so that was last year, and we're going to do LFS Bootscripts. And what we're going to do next, we need to do make install. And there's our Bootscripts by the looks of it. Cool, that's done. So I'm going to have a look at these Bootscripts because I usually just miss out this section because just installs a load of tools and it's the video will be ungodly long if we was like doing it in chapter 8. So it says check FS, checks the integrity of the file system before they are mounted, with the exception of journaling and network-based file systems. Okay. Clean FS, remove the files that should not be preserved between reboots, such as those in run, varlock. It creates a run UTMP and removes the possible present etc no login, passport, and force fusk files. Console loads the correct key map table for the desired keyboard layout, also sets the screen font. Contains common functions such as error and status checking that are used by several Bootscripts. Halts the system. IF down stops the network device. IF up initializes a network device. Local net sets up the system's host name and local loopback device. Okay, so that's your local host and your machine name. Okay, loads kernel modules listed in etc sys config modules using arguments that are also given there. Okay. Mount FS mounts all file systems except those that are marked no auto or are network based. Mount virt FS mounts virtual kernel file systems such as proc. Okay. Network sets up a network interface such as network cards and sets up the default gateway where applicable. Okay. RC, the master run level control script. That was the one that was on the previous page. It is responsible for running all the other Bootscripts one by one in a sequence determined by the names of the symbolic links to those other Bootscripts. Reboot systems, self-explanatory. Signals. Make sure every process is terminated before the system reboots or halts. So this will basically, yeah, say that it. I forget what it is. You can basically tell a process via standard input that needs to halt, and if you pick that up, it will just kill it. Forget what the network signal is. I should know this because I've actually done it in Go. Put this in my Go programs. Set clock resets the system clock to the local time, but the hardware clock is not set to UTC. Right, that might be that's kind of interesting. If you run a dual boot setup, Linux and Windows, they do times differently. I forget which one what does what. And it's easier to tell Linux to use tell it's using UTC or local time than Windows, then to set Windows to do the thing that is not that usually does the default. Forget which one it is, but it's on the Arts Wiki somewhere. And you usually have to do it on like most distros. So otherwise your clock's going to be like an hour out if you're between boot and Windows and Linux, like I do. Like I regularly dual boot between the two. IPv4 static voice functionality is needed to assign a static IP address to a network interface. That is like pretty important. Enables and disables swap files on partitions. Okay, so that's what swap on and off. loads system configuration values from the etc sysctl.conf that exists in if that file exists into the running kernel. So sysctl, you can set like number of open files you can have and a load of other bits and pieces. I've had them. If you've ever done any Node development with npm etc., Node will open so many file handles. It completely swamps. I think by default you're allowed about 10,000 as a user, or the system allows you 10,000 open file handles. You have to set it to like 500,000, otherwise Node will bomb out if you're trying to run a debug session in Node. Whereas other things I don't think do. Node's a bit of a mess. I hate dealing with Node. Unfortunately, I've got to do it as a day job. I think it's absolute garbage, Node. syslogd starts and stops the system and kernel log daemons. Okay, we compiled that, I think, in the last chapter. A template to create custom boot scripts for other daemons. Okay, prepares the dev directory and starts the udev daemon. Okay, we compiled that in the, I think, as part of the system D package. Udev retries failed udev u events. It copies generated rules files from the run udev to etc dev rules d if required. So, okay, I'm not sure what that means. We'll find out. Sorry, I'll just take some water. In Chapter 8, we installed a udev daemon when udev was built. Before we go into details regarding how udev works, a brief history of previous methods of handling devices is in order. Linux systems in general traditionally use a static device creation method whereby a great many device nodes were created under dev. Sometimes literally thousands of nodes required, regardless of whether the corresponding hardware devices actually existed. This was typically done via a make dev script, which contained a number of calls to the make nod program. Just thinking of like Command and Conquer now. I was playing it recently. With the relevant major minor devices numbers for every possible device that might exist in the world. Okay, that just sounds very inefficient. That sounds like something they did at the time because they didn't have a better solution. Using the udev method, device nodes are only created for those devices which are detected by the kernel. These devices nodes are created each time the system boots. They are stored in dev temp fs file system. A virtual file system resides entirely in system memory. Device nodes do not require much space, and the memory that used is negligible. Okay. I'm not going to read through this history because it's just not relevant. Basically, after kernel 2.6, they used something called sysfs, and originally they tried using something called devfs, and it basically it didn't work. Is all that says there. Right, so udev implementation, sysfs. The sysfs file system was mentioned briefly above. One may wonder how sysfs knows about the devices present on the system, what device numbers should be used for them. Drivers that have been compiled into the kernel register, their objects in sysfs, dev, tempfs internally as they are detected by the kernel. For drivers compiled as modules, registration happens when the module is loaded. Once sysfs file system is mounted on sys, data which the drivers have registered with sysfs are available to use space processes and udevd for processing, including modifications to the device nodes. Okay. Device node creation. Device files are created by the kernel in dev tempfs file system. Any driver that wishes to register a device node will use the dev tempfs via the driver call to do it. When a dev tempfs instance is mounted in dev, the device node will initially be exposed to user space with a fixed name, permission, and owner. Short time later, the kernel will be sent a U event to udevd based on the rules specified in the files within the etc udev rules.d, usrlib udev rules.d, and the run udev rules.d directories. UDEV will create additional symlinks to device node or change its permissions, owner, or group, or modify the internal udevd database entry name for that object. Rules in these three directories are numbered, and all three directories are merged together. If udevd can't find a rule for the device it's creating, it will lead to permissions and ownership of whatever dev tempfs used internally. Okay. I'm gonna be quite honest. A lot of that kind of flew over my head. It's something when they have these long explanations until I actually see, I actually have to deal with it. It doesn't really sit in my head. I'm very sort of like, I like doing a thing, and that's how I learn to do it. Reading this doesn't mean a lot to me a lot of the time. However, you should read it, so at least you know it exists. And you can refer back to it and then try to work out what's happening. But this is a bit too low level. But we are building a Linux distro. Not a Linux distro, a Linux system from source code. So we're going to have to delve into some of these very low level bits and pieces. So we're going on to module loading. Device driver compilers modules may have aliases built into them. Aliases are visible in the output of the mod info program and are usually related to the bus specific identifiers or devices supported by a module. For example, the SND FM 801 driver supports PCI devices with the vendor ID 0x11319 and device ID 0x0801. They're probably hex numbers for something. And how does an alias of, I'm not reading that out, that's ridiculous. For most devices, the bus driver exports the alias of the driver that would handle the device via sysfs. E.g., the sysbus PCI devices, some zeros with a D, mod alias file might contain the string. Oh, I'm not reading that out. That's ridiculous. It's PCI with a lot of digits under it. The default rules provided with udev will call udevd to call out to sbin mod probe with the contents of mod alias event environment available, which should be the same as the contents of the mod alias file in sysfs. Thus, loading all modules whose aliases match the string after wildcard expansion. I need a diagram to understand what that means. In this example, this means in addition to the SND FM 801 and the obsolete and unwanted Forte driver will be loaded if it is available. See below ways in which the loading of unwanted drivers can be prevented. Yeah, you basically just blacklist them. There's a blacklist. So you can blacklist a driver. The kernel itself is also able to load modules for network protocols, file system, and NLS support on demand. So when you plug in a device, such as a USB MP3 player, nobody has those anymore. Come on. What is this, 2005? The kernel recognizes the device is now connected and generates a U event. The U event is then handled by the udevd as described above. Right, now, I'm going to take a sip of water because this is brutal. There are a few possible problems when it comes to automatically creating device nodes. UDEV will only load a module if it has a bus specific alias and the bus driver properly exports the necessary alias to sysfs. In other cases, one should arrange module loading by other means. With Linux 6.13.4, I think that's basically one of the latest kernels. UDEV is known to load properly written drivers for input IDE, PCI, USB, SCSI, Serial, and FireWire devices. FireWire, if you don't know, is an old standard for connecting high-speed devices. It's kind of like superseded by USB. It was used in a lot of Apple stuff. To determine if the device driver you require has necessary support for UDEV, run mod info with the module name as the argument. Now, try locating the device directory in the sysbus and check whether there is a mod alias file there. If the mod alias file exists in sysfs and driver support the device, you can talk to it directly, but doesn't have the alias. It is a bug in the driver. Load the driver without the help from UDEV and expect issues to be fixed later. If there is no mod alias file in the relevant directory under sysbus, that means the kernel developers have not yet added module alias support to the bus type. With the Linux 6.13.4, this is the case with ISA buses. Expect this issue to be fixed in later kernel version. ISA buses, that's like Asian. That's like Pentium, isn't it? ISA buses. I'm sure that's like Asian. UDEV is not intended to load rapid devices such as sound, PCM, OSS, and non-hardware drivers such as loop and all. Oh, this is brutal. If the wrapper module only enhances the functionality provided by some other module, e.g. sound, PCM, OSS, enhances the functionality of SN PCM by making the sound card available to the OSS applications, configure modprobe to load the wrapper after UDEV loads the wrapped module. To do this, add softdep line to the corresponding etc modprobe the file name comp, for example. So they've got I'm not going to remember any of this. Softdep send PCM post send PCM OSS. So you basically have to add a line into a file somewhere into the Oh, I get this, right. So you basically just telling the driver to load his wrapper after it loads up. Okay. Note that the softdep command also allows pre-dependency of a mixture of both pre and post dependencies. See modprobe the manual page for the information on softdep syntax and capabilities. Okay. If the module in question is not a wrapper and it's useful by itself, configure the module's Bootscript to load this module on the system boot. To do this, add the module name to the ETT sysconfig module files on a separate line. This works for wrapper modules too, but it's suboptimal in that case. UDEV loads some unwanted modules. Either don't build a module or blacklist it in the etc modprobed.blacklist.com. Now, this is, I think, Arch Linux. There's like a file and part of the make init CPIA file. And when it has a list of blacklisted modules that you can add in there. And this is like, so for, you don't want necessarily Nouveau if you're using a new video driver. So you blacklist Nouveau. Yeah, so you basically blacklist in that file, and then you put blacklist forte in this blacklist comp. So you blacklist molecules can still be loaded manually with the explicit modprobe command. So modprobe is like load a module, modprobe whatever it is. Be honest, you don't have to do much of this in modern Linux systems. The distro people do. The people who distro maintainers do most of this stuff for you, I think. And it's only if there's a issue with that do you then have to get into it. But reality, you don't have to do this as much anymore. This is why a lot of this is done by the distro maintainers and all the testing they do, I suspect. Right, UDev creates devices correctly, makes the wrong symlink. So this is this process I was talking about up here. Yeah, so this usually happens if a rule unexpectedly matches the device. For example, poorly written rule can match both SCSI disk and a corresponding SCSI generic device incorrectly by a vendor. Find the offender rule and make it more specific with the help of udev adm info command. Yes. I think I've run that before. Well, I wasn't really sure what I was doing. That's most of my time doing anything low level with Linux. One of the reasons why I did this. The udev rule works unreliably, isn't that the same as above? This may be another manifestation of the previous problem. Well, yeah. If not, and your rule uses sysfs attributes, it may be a kernel timing issue to be fixed in later kernels. Okay, so it could be a kernel bug. For now, you can work around it by creating a rule that waits for the use sysfs attribute and appending it to etc udev rules the wait for sysfs rules file. Create this file if it does not exist. Please notify the LFS development list if you do so and it helps. Okay. UDev does not create a device. First, be certain that device driver is built into the kernel or already loaded as a module and that UDev isn't creating a misnamed device. If a kernel driver does not export its data by sysfs, UDev lacks the information needed to create a device node. This is most likely to happen with third-party device drivers from outside the kernel tree. Create a static device node in USR lib udev devices with the appropriate major minor numbers. See the file devices.txt inside the kernel documentation or the documentation provided by the third-party driver vendor. The static device node will be copied to dev by udev. Now, this is that's likely to happen if you're, I don't know, so there's basically no open source driver. The vendor has a driver and you have to install it yourself. Maybe that happens with the proprietary NVIDIA drivers. Device naming order changes randomly after rebooting. This is due to the fact that UDev by design handles U events and loads modules in parallel, and thus in an unpredictable order. This will never be fixed. You should not rely upon the kernel device names being stable. Instead, create your own rules that make the symlinks and stable names based on some stable attributes of the device, such as serial number or the output of various *_ID utilities installed with UDev. And they basically talk to the next sections. Right. UDev by default names network devices according to firmware BIOS data or physical characteristics of the bus, slot, or MAC address. Purpose of this naming convention ensure that the network devices are named consistently, not based on the network card, when the network card was discovered. In older versions of Linux, on a computer with two network cards made by Intel or Retec, for example, the network card manufacturers by Intel might have become E0, while the Realtek card became ETH1. After a reboot, they will be renumbered. So if I do IP ifconfig, do I have ifconfig? It's been ifconfig IP. Forgotten the yeah. So that they're talking about this device here, ENP1S1. That is an NP1S1. So these are always not the same. These will all be the same. So in a new network scene, network device are named by are something like ENP5S0 or WLP3S0. If this naming convention is not designed, a traditional naming scheme or custom scheme can be implemented. I don't care about that. Disabling persistent naming on the kernel command line. Traditional naming schemes such as ETH0, ETH1, etc. can be restored by adding .if names equals 0 in the kernel command line. This is most appropriate systems that have just one Ethernet device of particular type. Laptops often have two Ethernet connections named ETH0 and WLAN 0. So laptops can also use this method. No, I like this one. This is good. Command line. The command line is in the grub configuration file. Okay. Right. Right. Create the UDEV rules. Right. We actually get to do something again. Naming scheme can be customized by creating custom UDEV rules. A script has been included yet generates the initial rules. Generate these rules by running this. Now inspect the etc udev rules.d 70 persistent net.rules file to find out which name was assigned to which network device. Okay. Well, I haven't got any. Why haven't I got any? Why? So I definitely have a network devices there. So wait a minute. Let's just read what this script's doing. Ah, it's bash. All right. So that's the path there. All right, look. Well, that's probably why it's not running. So yeah. So this doesn't seem to make any if it's, I suspect. So reading the script, just so, because I'm not commenting as I'm going along. It's, now I am in a kernel virtual machine. I'm not sure if it would match this one or not. So the troubleshooting section here. Oh, wait a minute, it says here. That's fine. In some cases, such as MAC addresses have been assigned to a network card manually or in a virtual memory, such as QEMU. Yeah, basically, or QEMU. QEMU? QEMU. Yes, the QEMU. Or Zen. The network rules file may be generated because addresses are not consistently assigned. In these cases, the method cannot be used. Okay, so that is fine. It's not doing that. So if we ever run this for real, I suspect we have to run this script. We boot up the system. Otherwise, you won't have any network, I'm guessing. So it's something to consider. Okay. CD-ROM sim links. Jesus Christ. Right. So do I need to read this whole thing out? So this is the same thing where it goes makes the CD-ROM. It basically makes a set of sim links. Right. So the script here that does it basically creates the CD and DVD-ROM sim links. Now, if I pull back the curtain a bit, we have SATA CD-ROM. So I don't know if it will create that. Let's find out. So what it says here, first the script can operate in bypass mode used by the default for USB and FireWire devices, where the rules it creates depend on the physical path of the CD or DVD device. So secondly, can operate in a by ID mode. Now, by ID is better. And the reason is if you ever change, you go, oh, I'll plug in something new and you change it, it doesn't stop your CD from DVD working. I've actually had this on Linux, on old versions of Linux, where, or even if you say I plugged in my current, so I've got an NVMe drive on my actual real system that's running the VM, and what happens is if I was to change the where they were, if I swapped over which discs was what, so if I put the Linux hard drive into where the Windows hard drive is physically plugged in and moved about, Windows would boot fine. It wouldn't give a shit. Linux would not. It'll go, the device ID is all different. And you'll have to go into the fstab file and go and change it. Now, I've definitely had that happen with with old SATA devices, and I'm pretty sure it would happen with the NVMe disk drives because so that's kind of physically where they plugged in. But if it was done by ID mode, but I don't know how you can mount it because it'll be a different device naming, but whatever. Yeah, where the rules it creates depend on the identification string stored on the CD or DVD device itself. Now, you'll get into a problem if the manufacturer has just copied the ID in, because basically there'll be a little bit of firmware. There'll be some sort of firmware or chip or something that goes, hey, I'm this serial number and I have this ID, blah blah blah, and it goes, tells the computer that. And what you have this sometimes with monitors. I've got 2 monitors, and sometimes on cheapo monitors, what will happen is they have to put in extra code to manage them identifying as the same monitor, and they're probably the same with hard drives and other bits and pieces. So it depends who the manufacturer is, whether they put like a proper serial, all the bits, the information in properly. And that can by ID can screw up as well. So maybe it is better if it's physical sometimes. The path is determined by the UDEV's path ID script, and the identification strings are read from the hardware by its ATA ID or the SCSI ID. So I have a SATA. So SATA is serial ATA, so that will have a serial ATA ID. So when I actually know something about something, this all makes sense. There are advantages to each approach. Yeah, that's what I've just been discussing with myself and anybody who's still watching this, me ramble about this. The correct approach depends on what kind of devices changes may happen. If you expect the physical path to the device, that's why it does it because it's not likely to change. If you put your hard disk in, and you're not likely to be swapping hard disks about, usually. If you expect the physical path to the device, that is the ports and or slots that are plugged to change. For example, because you plan on moving the drive to a different IDE port or a different USB connector, then you should use the by ID mode. On the other hand, if you expect the device, the identification to change, for example, because it may die and you intend to replace it with a different device that plugs into the same connections, then you should do it by the by path mode. So yeah, that makes sense. Okay. So I was wrong to say that the other one was crap, because it isn't true. If type change is possible with your drive, then choose a mode based on the type of change you expect to happen more often. Obviously, it says here is basically USB devices, because you just plug them in and out whenever and different devices. You shouldn't use by path ever, okay, because it doesn't make sense. Let's see what it says here. Well, I don't think I can do anything now, and I don't care about CD-ROM devices because I don't typically use them anymore. I do have some CDs, but that's just games. This is not relevant. However, if you have multiple CD-ROM devices, then symbols generated at this time may point to different devices than they point to your host device, because that's discovered in predictable order. This is. I'm going to leave that, and we'll come back to it if we need it. Right, dealing with duplicate devices. As explained in section 9.3, overview of device and module handling, the order which device with the same function appear in dev is essentially random. If you have a USB web camera and a TV tuner, sometimes dev video 0 refers to the camera and dev video 1 refers to the tuner, and vice versa after the reboot happens. For all classes of hardware except sound cards and network cards, this is fixable by creating UDEV rules to create persistent symlinks. The case networks is covered separately. We read that, and the sound card configuration can be found in the BLFS. Don't care about that at the moment. For each of the devices that it is like to have a problem, even if the problem doesn't exist in your current Linux distribution, find a corresponding directory under sys class or sys block. For video devices, this may be sys class video for Linux, video X. Figure out the attributes that identify the device uniquely, usually vendor and product IDs. Oh God, you're making me have to think. So let's just run this. Right, this is not relevant. Okay, I wish they said it might not be relevant. Right, back to something more sensible. General network configuration. I suspect I've probably missed the point of that entirely. And I'll run into some horrific issue later. Take me 5 hours to fix, like I had to do with my Debian installation the other day. Right, anyway, no more digressions. We're almost up to an hour, and I want to get through this chapter. The files in etc sysconfig usually determine which interfaces are brought up and down by the network script. This directory should contain a file for each interface to be configured, such as ifconfig xyz, where xyz describes the network card. The interface name, each zero, is usually appropriate. Each file contains the attributes of one interface, such as IP addresses, subnet masks, and so forth. The stem of the file name must be ifconfig. Okay. No, if the procedure in the previous section was not used, UDEV will assign a network card names based on the system physical characteristics, such as ENPS2S1. If you're not sure what your interface name is, you can always run IP link or ls syscat class net after you reboot your system. Interface names depend on the implementation and configuration of UDEV daemon running on the system. The UDEV daemon for LFS will not run until the LFS system is booted. So interface names on the LFS system cannot always be determined by running those commands on the host distro, even in the root environment. Can we not just do DHCP? I don't understand networking. I don't even know what the gateway is, the broadcast, or anything. All right, so what we need to do is ifconfig and ctc etc sys config. So that's the one we want to configure, ENP1S0. So DHCP, it looks like it's in the BLFS book. Okay. So Don't know if I config. What we're going to do, I was going to copy this into here and I'm going to edit it with, because I've got Vim on the system, right? So I have to rename that. So move ifconfig. What was the name? ENP1S0. They feel like I'm understanding this at all. Right, so we want it to come up at boot, blah, blah. Right, so what's it? I can't remember now. This is really jank. I know there's a way of doing it properly. Set or something. I think this is 0. Oh, that won't work. And that has to be 0. I'm guessing this is. I hope this is not different because I'm in a. And that is going to be. Thing is, I don't even know what. So. What is the topology of my network? I don't actually know. Because everything's DHCP instead of DHCP. Should actually probably find that out. Don't want to be 2. It can't be 12 because that's where that's where the Pi hole lives. So we're going to do 20. And hopefully that's complete with anything. Let's just guess. And I need to make this whatever that was. So that's EMP1S0. So we'll try that. And if we don't have network, we'll have to faff a bit, I guess. Does it not? See, inet.168.122. I reckon this is like some nonsense to do with the. Is that a real address or a fake address? I don't know. We can always fix it later. It's just a text file. Right. Right. I'm not sure. After reading, I should have read through some of that. There's some bits and pieces about network configurations and explains this file. So basically, the iFace name is ETH0. The service name is basically it's static. I think we don't have DHCP yet by the looks of it. Something we're doing the BLFS, I guess. Static IP and a gateway. Now, I'm not convinced they're going to work because there's some virtual network shenanigan stuff that's happening on the host machine. I am awful at networking. I'm absolutely rubbish. I know enough to go and basically get stuff on the network, and I can usually just try stuff until it works. That's my that's how I deal with networking a lot of the time, is try stuff until it works. Thing is, I'm still better than a lot of other people, which is terrifying. Developers. So networking is usually something I didn't really pay attention to it in university. I did remember how the CIDR addressing works. It's do this prefix nonsense. Did understand once upon a time, which is about 15 years ago, how that worked. You divide some bits by some others, and you can work out what ranges you get. I probably need to watch a video or study it again. It's something I'm just not interested in, and it just goes in one ear, comes out the other. I was just never particularly interested in this. I think this is something that should be done automatically for the most part. I find it very boring. Sorry. Right. So the one that is interesting is on boot command, because this is just gateway prefixes, usual stuff. So if the on variable is set to yes, the system 5 network script will bring up the network interface card during the system boot process. If it's set to anything besides yes, the NRC will be ignored by this network script and will not be started automatically. Interfaces can be manually started or stopped with the IF up and IF down commands. Yes, I've had to do that before. Before DHCP was a thing, and getting a network driver, and stuff like that. Like a lot of the time, your NIC won't work, and you'll have to get a driver off of some site from the vendor, and then put it out, burn it to a CD, and the CD will cost you like £1 because everybody used to rip you off back in the days on computer stuff, and then you'll burn like one thing to that CD, so you might want to get a CDRWs, and they were even more expensive, and then you used them once anyway, because the CDRW didn't work properly, and all that fun they used to have because there was USB sticks weren't a thing. I ended up using zip disks for a lot of stuff. That was the USB stick equivalent, and then IM Amiga went kind of bust at some point. Unfortunately, their zip disks were really good. It was like a massive floppy disk with like 250 megs on it. It was amazing at the time. So we're just going to leave it at yes. If we have to reconfigure this and we don't have networking, we'll just come back into Shrew. We'll faff around with it, and we'll get it working one way or the other. Creating the etc resolve.com. The system will need some means of obtaining DNS. So your name server is basically where it gets DNS from. And this is usually your router. However, I have a Raspberry Pi, which complicates things. I don't know on what part of the network it's in. So I'm going to have to go onto, you won't be able to see this. I have to find out where my Raspberry Pi is that's running Pi-hole, because I don't remember. So if I do ifconfig, I don't have ifconfig on Debian. So where is the DNS? This. Wouldn't it be the same on here because it has to use the same DNS? NS lookup google.com. Let's just try that. Of course, it's not. It's got a Nixcraft. So I know that network does not exist on my network because everything's 192.168.0. Whatever. I don't have any bloody. Why'd they strip all these tools out and stuff? Because there's a package on Debian somewhere that has the dig command, and I can't remember what it is. I don't want to have to look it up. Why'd they like? Do I have that? I'm just gonna fake this again, and we'll have to deal with it because got limited time really. So I do know your domain name. Do you know that one? No. At etcresolve.com. Yeah, so on the real network, I'm just going to put in the real network one in, and if we have to change it, we have to change it. 12. No. Just shouting at the computer. Sound like an idiot. I just don't know really what I'm doing. All right. We're going to call this Echo LFS. I'm just going to call. What's it? LFS. I'm just going to call it LFS. Why not? Right. So customizing the etc host file. So that has to be the so at etc sys All right, so basically it's just added stuff to the host file. So usually you have like a loopback. You have 1.1, which is you don't typically need this. I don't know if I have it in mind. So if let's just have see that we've got an cat etc hosts. So yeah, that is 1.1 is the computer name or computer name.lan, and localhost is always there. 127.0.0.1 and 127.0.1.1. So if you sort of like put in that as your host name, it will also come back. So it just knows where to find itself on the network. If you don't have that, it doesn't have that. So and I'm not going to bother with that because I don't care. That's an IPv6 rubbish. So there's somebody on Hacker News saying that IPv6 is going to save the world. I just don't care. So what we're going to do is do these first two because they're the ones that actually matter. The rest of it doesn't. So we're going to do. I don't like this cat stuff. I've got Vim on the system. I'll just use Vim. All right, I'm just going to bump that off. Probably want to keep. Tell you what, I'll just comment it out for now. Yeah, it says here. I could have just read the whole thing and then edited. I keep on making this mistake where I read bits of it and then I'm trying to figure out what I need to do, and then it tells me that it's optional. So it could be omitted, which is what I've done. All right, so 9.6 System 5 boot script uses and configuration. Sorry. How do the System 5 boot scripts work? The version of LFS uses a special booting facility named sysv init, based on a series of run levels. We went through this earlier. The boot procedure can be quite different from one system to another. The fact that things worked one way in a particular Linux distribution does not guarantee they'll work the same way in LFS. LFS is its own way of doing things, but it does respect generally accepted standards. So most distros now are System D. So the way LFS works is quite different. Here we go. There is an alternative. Like every single time I read something, I start talking about it, and he mentions it like literally in a paragraph below. Oh dear. There's an alternative boot procedure called System D. We will not discuss that boot process any further here, nor should you. No, I have no problems with System D. It seems to work fine on Debian. I know there's a load of controversy about it, and people don't like it for whatever reason. I don't care. I just want it to work properly. Simpler is always better. In my mind, System D is very simple from a user perspective. However, it apparently is huge. I kind of don't care generally, and size of stuff as long as it's not ridiculous. Because I've got a terabyte disk. My disks are 5 years old. I could buy 2 terabyte disks now, or 4 terabyte disks for a reasonable amount of money. Why do I care that something's like 30 megabytes of the sake of shit? Sys5 init, which we referred as the init from now on, uses run level schemes. There are 7 run levels, 0 to 6, because people they like number stuff at 0 because of maths. Number 0 to 6. He literally said it after I did. Actually, there was more run levels, but others are used for special cases generally not used. See Init 8 for more details. Each one of the 7 corresponds to actions the computer is supposed to perform when it starts up or shuts down. The default run level is 3. We went through those 5. The important ones are 3 and 5. Configure sysv init. During kernel initialization, the first program to run, if not overridden by the command line, is init. This program reads initialization from etc init tab. Create this file with this. Okay, cool. We're just going to do straight up do that. And we need to go to home. Right. Right, an explanation of this initialization file is in the man page for init tab. In LFS, the key command is RC. The initialization file above instructs RC to run all scripts starting with an S in the etc rcd.d rc5 rcsd directory. I thought that said 5 there. Followed by all the scripts starting with an S in the etc rcd.rc question mark D. I'm assuming that's like different numbers there. Allowing consolidation of all system parameters in this one file. As for debugging convenience, the function script also logs all output to run var bootlog. All right, that's interesting. Since the R directory is a tempfs, this file system is not persistent across reboots. However, it is pending to more permanent file var log bootlog. I wonder if you have one of those on Debian. See, let's just go to cd var log zboot. Yeah, there's a bootlog. Look, interesting. I didn't know there was bootlog. I've been using Linux for quite a long time. Didn't know it was there. Let's go back to here. Keep on reading. More permanent file at the end of the boot process. So every time you reboot, it will presumably make this var bootlog, and that is why you can see there's 7 of them. I've probably rebooted this machine like 7 times, guessing. 8 times because it starts at 0. Okay. Changing run levels. Changing run levels done with init run level, where run level is the target run level. For example, to reboot the computer, a user issues init 6 command, which is an alias for the reboot command. Likewise, init 0 is an alias for the halt command. There are a number of directories under etc rcd that look like rc question mark -d, where the question mark is the number of the run level, yeah. And rcs.d all contain a number of symbolic links. Some links begin with a K, the others begin with an S, and all of them have numbers following the initial letter. The K means stop kill a service, and the S means to start a service, okay? The numbers determine the order in which the scripts are run, from 00 to 999. The smaller the number, the sooner the script runs. Okay, so it just goes through from top to bottom. When init switches to another run level, the appropriate services are either started or stopped, depending on the run level chosen. So you can have 100 scripts, I'm guessing. I suppose if you needed more than 100 scripts, would that be a problem? Could you not do 000 and 999 and then have 1,000 scripts? I'm not, maybe. The real scripts are in etc rcd /initd. They do the actual work, and the sim links all point to them. K links and S links point to the same script in etc rcd d initd. This is because the scripts can be called with different parameters like start, stop, restart, reload status. When K link is encountered, the appropriate script is run with the stop argument. When an S-linked is counted, the appropriate script is run with a start argument. These descriptions are what arguments make the scripts do. So start, these are obvious. I'm not going to read those out through. Drill free the model way the way the boot press works. After all, it is your LFS system. I'll leave it as it is for the minute. Files given here are example how it can be done. More boot scripts. The etc rcd init.d udev script init script starts udevd, triggers any cold plug devices that have already been created by the kernel and waits for any rules to complete. The script also unsets the U event handler from the default sbin hot plug. This is done because the kernel no longer needs to call the external binary. Instead, udevd will listen on a network socket for U events that the kernel raises. Okay. The etc rc.d initd udev retry script takes care of retriggering events for subsystems whose rules may rely on file systems that are not mounted until the mountfs script is run. Okay. In particular, USR and var may cause this. The script runs after the mountfs script, so the rules, if retriggers, should be succeed the second time around. It is configured by the etc system config udev retry file. Any words in this file other than the comments are considered subsystem names to trigger at retry time. To find the subsystem for a device, use udev admm info attribute walk device, where device is an absolute path to dev or sys, such as dev sr0 or sys class rtc. So that was covered in module loading. Okay, this is set clock. Why call it a complementary metal oxide semiconductor? Just call it CMOS clock. People want to know what it is. Call it. They'll look up what CMOS means. Jesus. If the hardware clock is set to UTC, the script will convert the hardware clock time to the local time using the etc local time file, which tells the hardware clock program which time zone to use. There's only one time zone that's relevant. That's GMT, really. BST. There's no way to detect whether or not the hardware clock is set to UTC, so this must be configured manually. The set clock program is run by udev when the kernel detects the hardware compatibility upon boot. Now, there are systems that don't have hardware clock. Some old computers don't have them. So I have an Amiga, does not have a hardware clock. You can add one as a clock port on the Amiga 600 and 1200. Maybe it's just 1200. And then you can actually have a clock on an Amiga because otherwise there's no clock. So, you know, there's no idea of time on an Amiga. If you do not remember whether hardware clock is set to UTC, run by running hardware clock local time show command. I'm going to run this on. Okay. Right, so it's so this is 9 o'clock. So it's almost 9 o'clock now. So my system is the Debian system is set to British summertime. So British summertime is So basically, it's explain how this file works. And what this does is it's UTC 1. So that is, it sets UTC. This is a really long-winded way to set 0 or 1. What we're going to do, we're going to do this. And we are on UTC time. We're just going to leave that clock parameters thing because I don't know what it does. Apparently there's right, now we get to configuring the Linux console. I think I might split this into 2 videos, an hour and a half, and I've been rambling. Configuring the Linux console. This will be the last thing I do on this. And we'll stop at 9.6.6 because I want dinner. The section discusses how to configure the console boot script that sets up the keyboard map, console fonts, and console log levels. If non-ASCII characters, e.g. copyright sign, the British pound sign, and the euro symbol, will not be used and the keyboard is US one, much of the section can be skipped. Without the configuration file or equivalent settings in rcconfig, the console boot script will do nothing. Now, I've got a British keyboard, so we're going to have to do this. So the console script reads the etc sysconfig console file for configuring information, decides which key map and the screen font will be used. Various languages specific how-tos can be used with this. So does it have British in here? Oh, these are languages. Okay, not locales. Okay, language and locale are different. If in doubt, look in USR share key maps and USR share console fonts directories for valid key maps and screen fonts. So we definitely need. If we do LS, I think it's LS USR share key maps, and oh look, I386. Just in case I might have an Amiga keyboard. I think it's QWERTY. And then I'm guessing it's, yeah, there's a UK map there. So it's UK. So I've got UK map keyboard. So we're probably going to have to change something in here. There's a lot of bits and pieces in here. Actually, I'm going to stop here and we'll stop off from here. For me, this video has been a little bit confusing because this is getting into lots of bits and pieces that is very in depth, and a lot of this is in the Linux book if you do an install from manual install, and they've in my opinion they've done a lot better job at writing the instructions how to do this, because you do essentially the same thing in Arch Linux. Some bits are already done for you. Obviously Arch Linux doesn't use System 5. Some bits have been pretty interesting in here, but I found this a bit of a slog again. So I'm going to leave this here, and I'm going to stop recording here. And so that'll be the end of this video. And hopefully I'll see you in the video after this. I know this was a rambling mess, and I do apologise for that. So hopefully see you in the next video, and bye-bye.